All right, let's glue on that 1¼ inch PVC cap. Now the ChIMP will eventually have a head that's will mount on this neck pipe. But for now, until we get the ChIMP up and running and you get it balancing well, you just run it with this cap, which kind of represents a head. It's time to build the ChIMP's arms. Now, in the basic ChIMP, the arms are not motorized. There's no servos or anything like that. They're hard mounted, but they're fastened with a screw on each side so that they are removable, number one, and are positionable, number two. And the whole reason for the arms right now is, besides the fact it looks neat, they're there to actually keep it from smashing its face into the ground. Because when you first build the ChIMP, there's some adjustments that need to be made to get the balance relatively perfect. And the arms are there to keep the ChIMP safe. And so they're mounted out as shock absorbers, actually, but also because they look neat. We're currently now using, for the arms, 1-inch PVC pipe. And I'm gluing 1-inch PVC caps on the ends of what are the forearms. The forearms are 1-inch PVC by 10½ inches long. And there you have that. Now we're going to glue in the elbows. And these are literally 90-degree elbows used as elbows. So that's a 1-inch 90-degree elbow. And like I said, I'm building this in real time so you can see what it takes. You can easily build one of these. Once all the parts are cut, it takes probably less than an hour and a half to build the ChIMP. Just making sure that all the PVC glue is cleaned up. It wipes off very easily and you can not even tell it's there. These are the arm pipes, which are 1-inch PVC by 6½ inches long, gluing into the elbows. The ChIMP is designed to be modifiable, and the frame is designed to be extremely inexpensive. But yet, this robot, which you're building, probably costs something in the range of $60 for the frame, maybe a little less, depending on where you shop and what you already have laying around. But you can modify any part at any time. There are threaded glue-on fittings you can use if you ever want to thread anything on instead of just gluing it together. However, here we've basically glued almost everything. There's, like I said, the cross member to leg joint is screwed in. The neck is screwed in because the neck will be replaceable with another neck that'll hold the head eventually. Here I'm fitting the last piece of the arm, which is a slip joint. All these pipes are, all these fittings are slip fittings. And this is a 1 inch to 1 1/4 inch slip elbow. Acts as reducer, and also so we didn't have to use 1 1/4 inch pipe for the arms, which is too heavy for what we need here. Eventually you can motorize these arms, both in elbow and shoulder, and use grippers. But for now, this is just a safe, easy, nice way to get started with the ChIMP and protect the ChIMP while you're dialing in its motion system and the algorithm and the PID. More on that later. Don't worry about a thing. This is the last piece of the arm. Make sure when you build this that you set one arm for the right shoulder and one arm for the left shoulder. They can't both have their slip fittings going in the shoulder going in the same direction, or you'll be very disappointed and have to start over again with that. And I imagine this arm, if I had to guess, costs about $8 in parts, maybe a little less, because the fittings are way more expensive than the pipe. Now, I'm setting this at a 90 degree. I'm using the board to hold down the fitting so that it's flat, and then setting the angle of the arm. And once you set it, if you just prop it up and let it sit for 5 minutes, it's perfect. Now, I'm just slip fitting on the arms right now, just pushing them on the shoulders. It's a nice tight joint. And later we will put a screw through those as well to lock them in place. Those are not to be glued. Here's the front plate, or the front hip plate going on. I've screwed the screws in but left them slightly proud so that they'll fit in the holes that have been pre-drilled. And I'm using an electric driver now, but I'm not going all the way in with it. I don't want to strip it or pull the head through the PVC board. So I just take it in lightly, and then I finish this off so that I can actually feel the torque with a regular Torx screwdriver. This is the rear plate, hip plate, and it's got standoffs that I've secured for the O-drive board. You fasten all the standoffs to the board, then you mark their feet, then you go back and actually insert each one of the standoff mounting screws. And then you can remount the O-drive on these standoffs. This gives the O-drive some security and some protection, and still lets you access all the connections on the O-drive. These screws, which come with the standoffs, both sets of screws come with the standoffs, and you can purchase them from any number of sources, including Amazon. They do not come with these nylon washers, and you have to go to your local hardware store and pick up some nylon washers. This keeps the screws from grounding or shorting the board. Once we're finished installing all the screws, it's time to install the XT60 connector. That's the pigtail that's used to connect the battery to the O-drive. This connector has a positive and negative mark on it. Right now you can see the negative on the left-hand side. Black is negative, red is positive, and we're just going to use a good screwdriver for terminals to actually mount this pigtail. And you can retighten it later just to make sure that it's tightened. You have to hold this. You don't want to break a solder connection by over torquing it, but under torquing it would be bad as well. Now the O-drive board is mounted on the rear plate, and the rear plate, once again, you can insert the screws until they're just sticking out barely, find the holes with them, and then I will zip this in as well. for final torque, once again using a hand screwdriver. Now, these are the hoverboard motors. The hoverboard motors are installed with custom 3D printed holders or adapters. And when they come out of the 3D printer, you have to make sure that they're smooth, and if there's any small bits of plastic, you have to clean them up, and we'll show you how to fit them in just a second. But basically, there's the shaft of the hoverboard motor has a flat that's been machined into it, and these fit the flats and hold the hoverboard motor from having the shaft spin. But when they come out of the 3D printer, they're slightly large. So although they may slide in eventually, or at least a little, they generally are very, very tight and often stand proud, like this one is right here. So what we're going to do is we're going to take that adapter off the motor and clamp it vertically to a surface, to any surface, workbench or whatever. You can see it's clamped. Now we're ripping off a 2-foot section of this rosin paper once again, and I think that's 1.5 inch wide rosin paper, and using it to polish and reduce the outer diameter of the adapter until, and this takes trial and error and several fits, because you want a tight fit, but you don't want it too tight, and you don't want it to just slide in loosely. Now I'm going to refit it, and obviously it took more than one attempt to do this, but there you have it. In a perfect world, that was all that it took. I'm going to fit the same one on the other side, same way. And those hoverboard adapters are not glued in. They will be set screwed or screwed in when we do final assembly, and that's in the electronics section as well. And there you have the finished frame of the ChIMP. And it took a little less than 30 minutes for me to assemble this. Thank you very much, and watch for the electrical videos coming up.